I'm Michael Milch from Semantic Designs, principal engineer, mostly working on DMS and applications, which essentially analyzes and transformation of code with DMS. So we have lots of C++ programmers here, and I assume most of you have used the standard template library or Boost, right? So how many of you have actually transformed source code? And did you use any infrastructure for that? So that's where DMS comes in, because that's infrastructure for building transforms. Oops. So fundamentally, DMS is a generalized compiler. You can parse source code, you can analyze it, you can transform it to create some output, which you then format, and off you go. The difference to a normal compiler is that the output is not just your object file, but you can actually output the original source code with your modification in, or an output in a different language. And in order to configure this piece of infrastructure, we have some rule compiler, which can be instantiated with various languages, which includes your favorite language C++, but I'm sure we have some fancy for mainframe assembler, right? And if you do that, you can actually pass those languages to name resolution on it, and if you add some task definitions, you can achieve certain things like computing metrics, detecting clones, translating to a different language, or refactoring C++. So, sounds great. Huh? Now let's switch back to Clang, because I know it's your favorite infrastructure. And we can have a simple transform like A plus equal B. We want to translate it to A equal A plus B. That's how it looks like in Clang if you want to use tree transforms in Clang. I stole that from some slides that have been presented by someone else in the LLVM conference in 2013. I think everyone here has a tough time to try to figure out what that code does. It's essentially navigating the syntax tree by hand, trying to extract some information, copying some things, and reconstructing some tree, and finally replacing something in the original syntax tree. Pretty hard to follow, no one can really understand it, and it's hard to maintain. Now, the same kind of thing in DMS looks like this. You just write something that looks like C++, except for a few backslashes, which are kind of escapes. And for those essentially representing variables or placeholders and the things we want to rewrite, which we just have some type information which we steal right from the grammar in the C++ manual, your favorite Bible, Appendix A. We throw the rule just into a rule set, and then we apply our transform, and we fundamentally get the same effect. The difference being is that here we see clearly what we are doing. Some of you might not use like any parentheses, so we throw in a few more rules and eliminate those. So now C++ is a fairly complex language. Expressions can have side effects. And if we just use the rewrite as we just defined, we get some result we don't really like, because we duplicated our side effect and suddenly get undefined behavior for what was originally a correct program. In order to deal with that, you essentially can add a condition to the rewrite that says, this rewrite only applies if something else is true. In this case, the something else that's true is that we kind of apply some other rewrite set to A and compare that result to A itself, unmodified. And then we define essentially a rule that eliminates all side effects in our syntax tree, and we can use it as a test, and now our rule does not apply anymore. So if we would just deal with C, we would be done now. Unfortunately, it's C++, and it has some more problems for us. For example, we might have defined a plus equal operator for our special class, but we didn't bother with a plus, and we cannot rewrite it, or our plus has a different semantics, and we cannot apply our rewrite. So in order to do that, we actually have to prevent the rule to apply when we have a user-defined operator. We do that by essentially adding another condition. In this case, whether the condition checks whether A plus equal B uses a user-defined operation. And if so, we do not want to rewrite stuff. And we do that by essentially creating an external function we are querying, and we are pretty much done.
All right, Michael, thank you.